Hi, hello, I'm Kiran Kumar from Nature of Physics. Today topic is R circuit. Please do like and comment and subscribe my channel, students. Okay, so for pure resistive circuit, considering R is the resistance, V is equal V naught sin omega t is the applied voltage, current released from the applied voltage and current passing through the resistance. Here we can apply the KVL, student, Kirchhoff voltage law, that is sigma V is equal to 0, sum of the potential in a closed loop is equal to 0. So anti-clockwise direction, conventional direction is taken, sign convention, so that V is positive applied voltage, and next IR is negative, student, voltage across the resistance is equal to 0. So we got here V is equal to IR equation. From this equation I can write I is equal to V divided by R. See there, this is the first equation, applied voltage is replacing here, so that I will get I is equal to V naught sin omega t divided by R, student. But here V naught divided by R, which is equal to I naught, is the maximum current, student, maximum current, and next V naught is the maximum voltage, so that here I am getting I is equal to I naught sin omega t. This is written as equation number 2, student. Equation 1 is the applied voltage, equation 2 is the current in the circuit, R circuit. I is equal to I naught sin omega t. One thing we can notice here from equation 1 and 2, so sin omega t and sin omega t is there, student. That's why here current and voltage have the same phase, student. So proof also I can write phase difference is equal to phase of voltage minus phase of current. So phase is equal to omega t minus omega t is get cancel, so phi is equal to 0 I got. So here also I can write phi is equal to 0 because of here voltage and current have the same phase, both are parallel, student. And continuation, next diagram is representation is wave diagram, student. Current and voltage taken on the y-axis and time is taken on the x-axis. Here also diagram taken. Here this diagram on the x-axis is time and y-axis is V naught sin omega t and also I naught sin omega t, student. That is also represent applied voltage and current, student. See there clearly, voltage increases, current also increases, student. Okay, but there is a small difference between the current and voltage, student. So voltage is plus V naught writing here, current is representing plus I naught, student. Current and voltage have the same phase, see there, same phase, 0, t by 4, t by 2 and 3t by 4 and this is t, student. Okay, so this green color represent the applied EMF, student, and this pink color represent the applied current, student. See there clear diagrams are given about the voltage, current on the y-axis, time on the x-axis. This is the wave diagram, sinusoidal function, student. Okay, next I am going to find the instantaneous power, student. So the basic formula for power, P is equal to VI, student. So that P instantaneous power, P instant, which is equal to, here V is equal to, from equation 1, V naught sin omega t. Okay, and next current is I naught sin omega t, student. So in this equation P instant, which is equal to V naught I naught sin into sin square omega t, student. Okay, and second equation also we can write here P instantaneous, which is equal to V naught I naught sin square omega t is 1 minus cos 2 omega t whole divided by 2, student. Okay, now Continuation, here we have to write two values, student. One is the RMS voltage and RMS current, student. Here I can write IRMS is equal to I naught divided by root 2 and VRMS which is equal to V naught divided by root 2, student. I naught is the maximum current, V naught is the maximum voltage, so that P instant which is equal to here V naught I naught divided by 2, that is 1 minus cos 2 omega t, student. Okay. So next step, P instant which is equal to V naught by root 2, next I naught by root 2, 1 minus cos 2 omega t, student. So we are getting different equations for the instantaneous power, student. Okay. So that values also we can replace there, so that P instantaneous which is equal to V naught by root 2 is VRMS and I naught by root 2 is IRMS. So remaining is 1 minus cos 2 omega t, student. Okay. This value we will replace in the average power, student. Okay. Look at the board. So now average power, I am going to write the basic formula for the average power. Here I have a space, that's why utilizing this, student. Okay. See, average power V average which is equal to integral 0 to t P instantaneous power into dt, student, whole divided by integral 0 to t into dt. This is equal to 0 to t, P instant value replacing, that is VRMS IRMS into 1 minus cos 2 omega t whole divided by integral dt is t, so that we can replace 0 to t, lower limit to upper limit, student. VRMS, next IRMS divided by t into t minus 0 minus 0, student. Wait, student, this is this is the average power. Slowly I did mistake. First equation, P average which is equal to VRMS IRMS, student. This is the first equation. Next, P average which is equal to second equation I square RMS into R. Next, third equation, P average which is equal to V square RMS divided by capital R, student. This is the third equation. Very sorry, I did a mistake by slowly. Yes, student. Next I am going to write the power, student. Power on the y axis and on the x axis time taken. So this is the equation representation for the applied voltage, student, and applied current is red color represent, and the power graph we will get like this. The power is a scalar quantity, we will get both are positive loops only. Okay, student. And for that, from the instantaneous value, the current in the AC circuit is independent of frequency, student. So that frequency is remains constant with respect to resistance, student. So that here R is equal remains constant, student. Okay, this is the graph between the IRMS and frequency or angular velocity, student. Next graph is IRMS and resistance graph, student. So the basic formula is there, V is equal to IR, so that I inversely proportional to the R, student. So we will get the graph is here hyperbola, student. So this is the graph we will get. And power factor is there, student. for the power factor, so phi is equal to 0. Current and voltage have the same phase, student, so that this is 0, student. Cos 0, which is equal to 1, student. So now I can write this phi is equal to 0 here. Okay, student. So cos 0 is equal to 1 I am getting. And next, instantaneous power given here, and after that we can write average power, student, already just now completed. So average power here, this is also phi is equal to 0, student. We will get P average, which is equal to Vrms and Irms into cos 0 is equal to 1, student. Directly I am writing here, this is 1, student. Okay, this is clear information about the R circuit, student. Please like and subscribe.